The near future. Our planet is running out of energy sources, and the human population is growing. There's less free space on Earth every year. People have to move to other planets as soon as possible, but there isn't enough energy for spaceships and interstellar voyages. You're a member of a group of scientists searching for energy sources in the universe. Solar power, windmills, hydro, and thermal power plants. It's not enough. You offer an adventurous but risky idea. You want to create an object and accelerate it to the speed of light. This object will start generating infinite energy. Other scientists immediately reject this idea. Such an experiment can destroy the entire planet and even the solar system. If something moves faster than light particles, it creates a black hole. To reduce the risks, you suggest speeding up a small and thin object, like a simple needle. As soon as it reaches the speed of light and releases energy, special machines similar to solar panels will absorb this energy. Only 1 millisecond of moving at the speed of light will be enough for humanity. Then, the needle should be stopped. You suggest to slow it down with the help of Mount Everest. You want the needle to smash into it. As soon as you start working on the experiment, you face an unsolvable problem. An ordinary needle, like any other object with mass, can't reach the speed of light. According to the laws of physics, it's impossible. To do this, you need to turn the needle into a beam of photons. The metal of the needle will be erased into dust during acceleration to the speed of light. Earth's atmosphere shows strong resistance to a moving object. So now, you need to create the strongest durable material in the universe. It not only has to withstand the air resistance, but also not be torn apart by the energy growing in it. When any object increases its speed, its energy increases too. You need a lot of money to create such a needle, but before you get it, you have to conduct this experiment in a simulation program to prove you're doing the right thing. This program is a computer hologram of the solar system. The program imitates and visualizes all the laws of physics. You can run your experiment using this model, and if it goes well, you'll get money to implement your plan. So, you create a computer simulation of the needle. Then, you build a machine with an incredibly powerful engine. It works like a rocket. Several motors are attached to the needle. They help reach the speed of sound, then charge the needle with energy and release it. Using the charge force, the needle should accelerate to the speed of light and crash into Everest. You'd need to set the launch spot of the needle a long way from the mountain for the whole operation to work out. Air resistance greatly hinders the acceleration. The needle's path must pass through thousands of miles of free space. You decide that it's better to launch the experiment from space, where there's no resistance. To do this, you build a base on the moon in the simulation. Computers calculate the exact start time and needle position. You need to know the speed of the Earth's movement around its axis and the moon's movement around our planet. The slightest deviation from the course can cause the needle to crash into the ocean or a city. If it gets into the water, severe floods and tsunamis will happen all around the world. The computer calculates the ideal moment for the needle to fly. You're ready to start the operation. Scientists and presidents of different countries are watching the simulation. You're so nervous, you're sweating. You come up to the computer and press the start button. Everyone is looking at the big screen. A rocket with a needle placed on top flies up. It's rising high above the moon. It reaches the speed of sound. The first engine falls off. The rocket's mass decreases and its speed increases. Half the distance between our planet and the moon is gone. There's 2 engine turbines left. The speed of sound is exceeded by 10 times. The second engine falls off. The needle is approaching the Earth's atmosphere. The third engine generates a huge charge of energy, strikes it into the needle, and flies away. The needle turns bright red and hot like the sun. It penetrates the Earth's atmosphere. The protective layers of our planet can't prevent the needle from reaching its goal. The sky lights up with a bright flash. In the next half second, the needle will hit Everest at the speed of light. 2 seconds later, your experiment will fail. And here's why. The greater the speed of any object, the larger the mass and the amount of energy that accumulates inside. When the needle reaches the speed of light, its energy begins to increase indefinitely. The mass grows to infinity. And when this happens, a black hole is formed, a massive object with an incredible gravitational force that absorbs absolutely everything, even light particles, photons, and the time dimension. This is called the event horizon. Literally, everything that is an event, time, space, matter, is absorbed by the black hole. No one knows what is inside the black hole. After 1 millisecond, the needle almost reaches the speed of light. It releases a huge amount of energy into the atmosphere. If you look at it in slow motion, you can see how the air is ionized. That is, the air molecules are split. In nature, this process occurs during lightning flashes. Our sun also has ionizing energy and disinfects the air. The needle cuts through the Earth's atmosphere. The sky is lit up with a bright light. All the clouds and every water molecule around the needle instantly evaporate at the high temperature. The sky becomes crystal clear hundreds of miles around the spot. In the center of this clean circle is the needle, and it's approaching Mount Everest. Hundreds of thousands of tons of snow burn up as soon as the needle gets close to it. It has reached the speed of light. A thick layer of ground melts and flies away in different directions. It looks like someone has thrown a spear into an ice cream mountain. Everest can't handle so much energy and is torn apart into a million pieces like a sandcastle. The incredible power of the blast wave destroys everything around. Stone, wood, soil, leaves, concrete, everything falls apart into billions of pieces because of the powerful energy and heat. Then, all these molecules are erased. The needle moves faster than photons, and as soon as it overtakes the light, it starts to overtake time. From the needle's point of view, all events begin to go in reverse. The mass of the needle becomes infinite, and the greater the mass, the greater the energy. A burst of unthinkable gravitational force absorbs all space. Land, trees, nearby cities, the Earth's crust, and the core, everything disappears in a matter of seconds. A black hole absorbs light and time. An absolute black void has come. The black hole is growing. Holographic International Space Station is shrinking thanks to the strong pressure of gravity and is being pulled into a black void. Then it's the moon's turn. The force of gravity increases quickly. The hole is getting heavier and more massive. All the planets of the solar system collapse as the gravitational black giant grows. The sunlight goes in and never comes back. The black hole becomes thousands of times heavier than the sun. Our star splits into millions of thin strips of light, like spaghetti, and spits out powerful streams of energy. An empty sector of outer space with an expanding black hole is in the place where our solar system was just moments ago. Meteorites flying past it also fall into the trap. Just one small needle managed to cause such a disaster. The simulation ends. The program breaks down because it can't calculate further events. You realize it was a bad idea after all. You decide you'll try to get the energy from the Earth's core instead.